Hello, this is Ms. Nichols, and this video is on the variables we're going to use to describe circuits. The essential question is, how can I describe and explain what is actually happening inside the circuit? So today we're going to introduce 4 new physics variables, and these 4 variables may be words you've heard before, but this is going to be kind of when you're going to learn the precise physical meaning of voltage, current, resistance, and power. These variables are actually they are very interwoven. They're made up of different combinations of the fundamental variables we've learned about, like charge, energy, and time. Taken together, these 4 variables can describe how electrons move through a circuit and how they transfer the electrical energy from the power source to the resistor. The first circuit variable is voltage, and we're going to use a capital V to represent voltage. The units of voltage are joule per coulomb, or joule every coulomb, which is otherwise known as a volt. So a volt is just a simpler, easier way to write a joule per coulomb. But I actually kind of like using joule per coulomb better because it works with the definition. It helps you understand what voltage really is. So voltage is defined as the amount of electrical potential energy stored in each coulomb of electrons. So it's not the total energy in a system, but it's the energy for each one of those little electrons that's in your system. So for example, if you have a battery and that battery is taking electrons and pumping them from one side to the other, and you know that the battery uses up 60 joules of energy as 10 coulombs of electrons pass through, you could calculate out that the voltage of this battery is 6 joules per coulomb, or 6 volts. The second circuit variable is called current, and hopefully you've already heard that word in English. You have a sense that it somehow relates to the flow of things. In electricity, current specifically refers to the flow of electrons. The units for current are the coulomb every second, or coulomb per second. But again, there is a shortcut for that, which saves us some time. We call 1 coulomb every second an ampere, or an amp, or sometimes just an A. So the current, 1 amp, is defined as 1 coulomb of electron passing by every second. An important note here, this is not the velocity. It's not how fast the electrons are moving. It's how many electrons are going every second. So, for example, we've got a little light bulb in that circuit down there. If we knew that in 120 seconds, 30 coulombs of electrons pass through that resistor, we could say that our current is 0.25 coulombs every second, or 0.25 amps. Our third circuit variable is known as resistance, and the units of resistance are the ohm, which is written as a Greek symbol omega, which is this little upside down horseshoe thing. And resistance is defined as how difficult it is for the electrons to pass through part of a circuit. So it kind of works with the English definition of resistance too. It's how hard it is to get through. So for example, if you have 2 different wires here, you can see how that wire on the left would be a high resistance material because it's really long, right? And there's lots of things to bump into the electrons as they're moving, and there's not a very wide space for it to move through. So that would be a high resistance material. It would make it harder for the electrons to pass through. Whereas the thing on the right would be a low resistance material because it's very wide. There's a big opening for the electrons to go through, and there's not a lot of things that are bumping into those electrons, and it's a very short resistor. So in any case, it depends on the way the material is designed. So an example question, a 4 ohm toaster and a 1 ohm coffee maker are in a circuit. Which one has more resistance? Well, obviously the toaster, which means it's 4 times harder for electrons to get through that toaster than through the coffee maker. All right, so I saved the most important circuit variable for last, and that is power. Power is written as a uppercase cursive P. I don't know that that's the best symbol that I wrote right there, but it's kind of a cursive P. And the units for power are joules every second, which is otherwise known as a watt. You may have seen power written before on light bulbs or other devices at your house in watts. The reason power is important is because it is the amount of energy that is transformed every second. And that's really the point of a circuit, is to take electrical energy and turn as much of it as possible into other kinds of energy every second. So for example, if you knew a light bulb transforms 90 joules of energy into light in 30 seconds, well, the power rating of that light bulb would be 3 joules every second, or 3 watts. And that's pretty low for a light bulb. If you've seen lights in your house, they're more likely 40 watts or 60 watts or 90 watt light bulbs. And you can tell immediately when you look at two light bulbs, for example, which one is higher wattage, because the one that's higher wattage is going to be the brighter bulb. It's the one that's transforming more of that energy into light every second. So the bulb on the right is a higher wattage bulb right now than the one on the left. Okay, let's take a minute to revisit our essential question, which was, how can I describe and explain what's happening inside of a circuit using circuit variables? Answer that question in your notes, and then I would really recommend making some flashcards with these circuit variables in them and just going through those flashcards until you really know the definitions and the units of these variables backwards and forwards. So I would put like a V on one side, and on the other side I would write voltage, energy per electron, and then I would write 1 joule per coulomb equals 1 volt. I would say another card, current, I on one side, and then the other side write current, electrons per second, 1 coulomb every second equals 1 amp. Resistance is R, and we use the unit of ohms. And then capital P, or the cursive P, is power, and that is energy every second. And 1 joule per second is a watt. So I have some flashcards you're welcome to have if you'd like to come see me, but otherwise I would recommend making these at home. Thanks for watching.